Hello everyone. Today we start the next model. So if the question is like that, develop an inventory model with selling price dependent demand, demand rate for deteriorating item, with shortage. Okay, so first way to write the assumptions. So first step is assumptions. So from this it is clear that demand is selling price dependent. So we can write demand is selling price dependent. Okay, so how will be its expressions? How to write selling price dependent demand? So it will be D equals A minus BP, where A and B are constant. Also, A is greater than B, and there is one more, P is less than A upon B. Okay, this is the condition for this. And here these are constant and P is selling price. Okay, the next one is deterioration rate is constant. Third one, shortages are allowed. Fourth, lead time is 0. Now we go for the next step, which is notations. So we can say this is D. So D is a demand rate. P is a selling price. Okay. Now theta is the rate of deterioration, and its value always lies between 0 and 1. Now for the cost component, C1 is the ordering cost. C2 is the holding cost. Per unit time. C3, this is the deterioration cost. Per unit time. And there is one more cost regarding shortage, so we can say CS. This is the shortage cost. Per unit time. Okay, Q is the order quantity. B is the back order quantity. And T is the cycle. So these are the notations which are used throughout the model. Now we go for next step, which is mathematical modeling. Mathematical modeling. So first we draw the graph for this. So demand is selling price dependent. This is like that. Since the deterioration occurs, so it can't be uniform. So this is our inventory level. This represent the inventory level. Okay, this is our order quantity, and this represent the time. And the inventory is depleted due to the joint effect of demand and deterioration. This is time 0 to T1. Okay, now the inventory is gonna finish. Inventory become 0, and but demand is left. Okay, so there is shortage arising, and at time T shortage end. Okay, so this is some quantity which is known as backorder quantity. Okay, so how we can write it? We can write some theoretical part from this figure. Okay, so we can write in the beginning retailers order Q quantity from this supplier. After receiving the order, after receiving the order, retailer start their cycle. So after receiving the order, retailers start their cycle. So now the retailer inventory is depleted due to demand and deterioration. Initially, at time T equals 0, retailer inventory level is Q. Okay. After, in the time interval zero to T1, the retailer inventory depletes due to The joint effect of demand and deterioration. Okay. At time t equals to t1, the retailer's inventory becomes 0 and at that time shortage started. In the time interval t1 to t, shortages occur. Okay, so now we can write the differential equation for this. So the governing differential equation is given by dit upon dt equals minus d in the value of d a minus bp. Okay, minus theta it, and we can write it dit upon dt plus theta it equals minus a minus b, and this is in the interval 0 to t1. Now for the interval t1 to t2, the differential equation becomes d of it upon dt equals minus d. Now this is for interval t1 to t. We can say this is equation first. Now boundary conditions are at t equals 0, I0 is q, t equals t1, I of t1 is 0, and t of t, I of t become minus b. Okay. So now from equation first, we have dit upon dt plus theta it equals minus of a minus bp. And from this equation, we can easily solve because this is a linear equation in it. So we can find the integrating factor that will be e to the power theta t. So its solution will be it e to the power theta t equals minus of a minus bp e to the power theta t dt plus a constant c. So it becomes it e to the power theta t equals minus of a minus bp e to the power theta t upon theta plus c. Now we use the boundary condition. So at t equals t1, I of t1 equals 0. So this becomes 0 and this is equals a minus bp e to the power theta t1 upon theta plus c. So this implies that the value of c is a minus bp e to the power theta t1 upon theta. So the value of it is, we can take this as common. So it will come and divide throughout by e to the power theta t. So we get a minus bp upon theta e to the power theta t1 minus t minus 1. And this is for the interval 0 to t. We can say this is equation third. Now using the first boundary condition, we can find the value of order quantity. So here we get it equals a minus bp upon theta e to the power theta t1 minus t minus 1. So when we apply the first boundary condition that at t equals 0, I of 0 is q. So it will come q equals a minus bp upon theta, and this will come e to the power theta t1 minus 1. So this is the order quantity. From equation 2, dit upon dt equals minus of a minus bp. Okay, so we can easily solve it. So we get it equals minus of a minus bp t plus a constant c dash. Now we can use the boundary condition. So at t equals to t1, so it will come 0. So 0 equals minus of a minus bp t1 plus c dash. So from this we get c dash equals a minus bp of t1. Okay, so it will be we can take a minus bp as common. Now we get t1 minus t. So this is the inventory level in the time interval t1 to t. Now we can find the backorder quantity. Since we have last boundary condition that I of minus t is minus b, so we can use this for finding the value of backorder quantity. So now at t equals to t, I of t is minus b. So this will come minus b equals a minus bp t1 minus t. So we can it can be written as b equals a minus bp t minus t1. So this is the backorder quantity. Okay. So now the next step, we can say this is equation third and this is fourth. Now we go for the next step, which is inventory cost. Okay. So first one is ordering cost. So this will come C1. Now the second one is holding cost. This is equal to per unit holding cost time, since the inventory is held in the time interval 0 to t1. So the limit goes to 0 to t1. It dt. So now we can put the value of it here. So we get a minus bp upon theta e to the power theta t1 minus t minus 1. Now we can solve it. We have this one, holding cost equal c2 0 to t1 A minus Vp upon theta e to the power theta T1 minus T minus 1 dt. So this will come C2 A minus Vp upon theta, and we can easily integrate it. So it will come minus of Vp power theta T1 minus T upon theta minus T. Now we can put the limit. So this will come when we put T1, so it will become 0. When we put 0, then it will come theta T upon theta minus T1. We can take LCM, so it will become C2 A minus BP upon theta square, and this is e to the power theta T1 minus theta T1 minus 1. So this is the holding cost. Now we find the deterioration cost. So this will come C3 0 to T1 theta IT dt. There is a relationship between holding cost and deterioration. Just multiply with theta in the holding cost, then you get the deterioration cost. So no need to find this like that. But it is only when if theta is constant. If theta is time dependent, then it will change. So it become C3 A minus BP theta upon theta square e to the power theta T1 minus theta T1 minus 1. So this is deterioration cost. Now we find the next cost, which is shortage cost. So this is minus CS. Shortages occur in the interval T1 to T and IT dt. So this will come minus CS T1 to T, and its value is A minus BP T1 minus T dt. So we can easily solve it. Minus CS A minus BP T1 to T. So it will come T1 T minus T square by 2. So it can be written as minus CS A minus BP. Now we can put the limit T1 minus T square by 2 minus T1 square plus T1 square by 2. After simplification, we get CS A minus BP T square minus 2 T1 T plus T1 square by 2. So this is shortage cost. Now the total cost will be ordering cost plus holding cost plus deterioration cost plus shortage cost. Okay, now we put the value of all each. So the total cost become ordering cost is C1, holding cost is C2, A minus BP upon theta square e to the power theta T1 minus theta T1 minus 1 plus deterioration cost is C3 theta A minus BP upon theta square e to the power theta T1 minus theta T1 minus 1. And shortage cost is CS A minus BP upon 2, and this is t square minus 2 t1t plus t1 square. Okay, so now the total average cost will be so ATC. This will come C1 by T plus we can combine both these, so we get C2 plus C3 theta A minus BP upon theta square T e to the power theta T1 minus theta T1 minus 1 plus Cs A minus BP upon 2. When we divide it by T, then we get T minus 2 T1 plus T1 square by T. Now this is the cost function, average cost function. Now we aim to minimize the cost function. So we use the principle of maxima and minima here. So for this, since this is the function of two variable function, first variable is t and second is t1, so we will differentiate with respect to partially differentiate with respect to t and t1. Okay, so now we find dATC upon dt. So it will come minus C1 upon T square minus C2 plus C3 theta A minus BP upon theta square T square e to the power theta T1 minus theta T1 minus 1 plus Cs A minus BP upon 2 1 minus this becomes 0 because we are doing partially differentiate minus t1 square by t square and this is equal to 0. Now we take the coefficient of t square in one side and another in one side. So we get 1 upon t square c1 plus c2 plus c3 theta a minus bp e to the power theta t1 minus theta t1 minus 1 upon theta square plus Cs A minus Bp T1 square by 2 and this is equal Cs A minus Bp upon 2. Now T square will be C1 plus C2 plus C3 theta A minus Bp e to the power theta T1 minus theta T1 minus 1 upon theta square plus Cs A minus Bp T1 square by 2. Okay, and this 2 is multiplied with so 2 and this is on upon Cs A minus Bp. So the value of T will be square root of all this. Now we will differentiate it with respect to T1. So we get T square equals 2 upon Cs A minus Bp into C1 plus C2 plus C3 theta A minus Bp e to the power theta T1 minus theta T1 minus 1 upon theta square plus Cs A minus Bp T1 square. So T will be square root of 2 upon Cs A minus Bp C1 plus C2 plus C3 theta A minus Bp e to the power theta T1 minus theta T1 minus 1 upon theta square plus Cs A minus Bp T1 square. So this is the value of T. Now to find the value of T1, uh, mm, differentiate partially with this one is average total cost. So differentiate it with respect to T1. This is T minus 2T1 plus T1 square by T. So again we can write it C1 by T plus C2 plus C3 theta A minus Bp e to the power theta T1 minus theta T1 minus 1. And we can write it this one T square minus 2T1T plus T1 square. Now differentiate it with respect to partially with respect to T1. So it become 0. It become C2 plus C3 theta A minus Bp, and this is theta e to the power theta T1 minus theta upon theta square T plus Cs A minus Bp upon 2T, and this is 0 minus 2T1 plus 2T. This will be 2T, capital T, and this will be 2T1, and this is equal to 0. So after solving it, we get C2 plus C3 theta. We can divide, this is T, this is T, so when we multiply with 0, it becomes 0. From this, we can take theta as common, so 1 theta will be cancelled out, and it become, we can expand it, so 1 plus theta T1 minus 1 and plus Cs A minus Bp 2 can be cancelled out, so it becomes T1 minus T, and this is equal to 0. After solving it, we get C2 plus C3 theta, T1 plus CS A minus BP, T1 minus T, and this is equal to 0. Okay, now we can take T1 as common. From this we get T1 equals CS A minus BP upon C2 plus C3 theta we can write it here. So T1 will be C2 plus C3, sorry, T1 will be CS A minus BP T upon C2 plus theta C3 A minus BP plus CS into A minus BP. So this is the way. Now for the minimum condition, we find del 2 ATC upon del T square into del 2 TC upon del T1 square minus del 2 TC ATC upon del del T1 whole square, and this will be greater than 0. So this is the whole process to solve this type of model.